Hello, everyone. Nice to see you all here. Thanks for making the time to come attend this session. My name is Vinoth Chandar. I'm the creator and PMC chair for Apache Hudi, which is one of the data lakehouse, and we'll get into what that means in some slides. I'm also a startup founder. I started this company called Onehouse, and which builds on some of these principles that we cover here as well. Before we dive in fully, also a huge shout out to the team here for organizing this event, and also I want to take this opportunity to also, as a avid data engineering weekly reader, thank Anand for all his tireless efforts to educate the community over the years. That's one of the he's put a lot of time and dedication into this over the years. It's kind of like amazing to see. Cool. So a little bit about myself. Like I mentioned, I'm passionate about data, distributed systems, databases, and I started my career at Oracle working on capture, sort of like CDC systems. Then led the key value storage team at LinkedIn through a few other projects. Then I was there at Box for a brief period where I was working on their internal, kind of like a real-time store. Then at Uber, I spent almost 5 years there building out a lot of the foundational data infrastructure for the company. We ended up creating Hudi because of some of these challenges that we faced with scaling our data platform at Uber. And right before Confluent, I was a principal engineer working across Kafka, KSQL, stream processing in general. So yeah, for today, I think we have like a pretty fancy title, but the idea that we're going to share today is actually pretty simple but very powerful. And essentially, we're going to look at how data infrastructure has evolved. If you heard about these terms, data warehouses, data lakes, data lakehouses, what do they really mean, right? We'll go into that. And then I want to touch upon like an aspect that is kind of lost in a lot of the, the conversations right now. It's not covered around how the data lakehouse can, or this architecture can actually change data, and then how it can set up organization for success. Then we'll talk about like a blueprint of like an opinionated way of, hey, here is how we can build this using these new technologies, combination of these technologies, and here are some of the benefits that you will see out of that, right? So quickly, right? So let's start with the basics. How many of you here know data warehouses? Almost everybody. The databases for analytics, transactions, strict schemas, and columnar file formats. They're optimized for analytical queries. They've been around for decades, right? And on-prem data warehouses have this shared nothing architecture that you see, where the data is stored on local storage, and everything, it works like a distributed database, basically, right? And that's because the local storage can be faster in a lot of cases. And you can actually see a good kind of side notice. You can see real-time analytics systems still favor this kind of architecture for the same reason. Then, the next generation warehouses, the biggest problem with on-prem data warehouses was that the data volumes can grow very big, and then you can't scale both compute and storage independently, right? So this was like the big idea for most of these cloud data warehouses. You can see in this architecture, data sits in a cloud storage. There's a cache on every node. Then pretty much, and then most of these are fully managed services, which mean you pay as you go. The experience is very and reduced maintenance. There's no DBAs or anybody required. It's fully managed, and most of these pull some of these core aspects of managing the warehouse into like platform level services, right? And they're typically optimized for BI workloads. There's a bunch of things that go on. They are local SSD caches, like database indexing. They have far more mature optimizers, at least in my opinion, because they've been just like at that problem for much longer. And then we touch upon data lakes. How many of you know? Awesome. And it'll be interesting to see, what these answers would be. We can allow to actually chat with a lot of you to understand. So what I found in my experience is, if you ask people what a data lake is, it really depends on who you're asking. To me, I learned about it from this blog where it discussed it as an architectural pattern that separated raw and derived data. But most commonly what I've heard is, okay, file sitting on cloud storage, it can be in any format, unstructured, schema and read, bunch of things like that, right? But fundamentally, if you now again touch upon the architecture, it's a very simple thing. Let's file sitting on cloud storage. You have implicitly compute storage separation, right? There are no long running servers here. Things come, write, things come, read, and then it's a very on demand kind of architecture, right? Serverless, if you will. And then most of the use cases for this is parallel data processing, right? As you can imagine, like there is, lots of data, scalable, it can crunch a lot of data very fast. But the thing is, it's actually very hard to build and manage. You need to really optimize. You almost are building by hand, like like all the tuning and everything, the layout, everything you need to take care of to be successful at this. And also you need to ensure data quality, right? So these are like some big challenges in data lakes. The data lakehouse is kind of like a relatively new. I say relatively because we're talking about things that are decades old and like couple of decades old, right? So 5 years old. What the data lakehouse model really does is it takes data lakes and adds like a transactional layer, right? It basically adds the ability to update, deletes, concurrency, control, and a lot of you may have heard about these 3 projects in the space right now which offer some of these capabilities, right? And then you get table level abstractions. You're not dealing with objects anymore. You can do, at least speaking for Hoodie, we up-level the management of files and data optimizations, like and most of these systems store table metadata in more metadata files. And again, this is another aspect that we focused on a lot for 5 years, which is how do we now use this to, remember how I talked about data lakes primarily were used for crunching data. How do you crunch faster, right? So change streams, incremental queries, indexing for kind of faster merge, less data. So these are all like kind of some of these things that the data lakehouse brings, and it kind of causes some kind of like a good convergence path. So you have on-prem data warehouses, you have data lakes that started with MapReduce and stuff. If you see steadily, we got serverless, we took cloud data versus prime time, and Snowflake famously decoupled and brought this like nice user experience, seamless experience, right? And you have the cloud warehouse of today. And on the other side, you have Spark, which is probably the first real general purpose compute engine which can do arbitrary DAGs, right? If you've written pig and MapReduce programs, you'll appreciate what I'm saying. And then we created Hoodie 2016. This is the first kind of, we called it a transactional data lake. We didn't coin the term lakehouse. And then Delta Lake, and if you look at it, we now have like a lakehouse kind of system. And naturally, it's a lot, right? So quickly, if you look at it, warehouse lakehouse, there is, open data formats. Everybody talks about it. We think I'll touch upon some of these lock-in points as we go. But, I think we've all come to this point where we say, okay, companies have to embrace open data formats. Warehouses, they have proprietary formats and interoperability with open. Well, lakehouses are built on open data formats or file formats. Fundamentally, the data is stored on a warehouse with the vendor. Typically, access is through, across accounts. This means if you need to process data, right, in your own network, with a VM running in your own network, you need to somehow like pull it across from the vendor network, right? In the lakehouse model, the data lives in your own cloud bucket, and you can have access to it within your account for most part. So data services, this is one of the aspects actually where are proprietary in warehouses, and this is the area where actually a lot of kind of lock-in is created, because you get used to a service doing things to your table and data, and then it cannot function really if it stops doing that, right? The query performance will be bad or things like that. So even on the lakehouse space, most of these are actually locked to vendors today. And we've always built with Hoodie, at least we have built in a different way where we made opinionated choices on service. This is as one of the more key lock-in points, I would say, right? So just to summarize, before we go, this section is most so that we can digest, when we talk about the architecture downstream. Warehouses typically built for BI. The problem they solve is they try to solve the least scan the least amount of data possible, right? They use performant metadata in databases. So think about, doing a SQL to plan your, quickly get the stats, right? So they're always going to be like faster. That architecture is going to be faster for those things. And they have long running servers, which means they can cache things. They need not like, they're more performant for these like interactive or BI kind of queries, right? Lake supports scalable kind of like scanning of vast amounts of data. So they have direct access to cloud storage, no intermediate servers. So if you think about it, if you have a 10 node warehouse in front, 1,000 core Spark job, that warehouse layer is going to be a bottleneck, not cloud storage, right? So this hits cloud storage directly, no intermediate servers, rich support for data frameworks and stuff, and Lakehouse are kind of trying to blend both, but there's still open challenges. We still need to get better at query planning. Like I mentioned, there is a lot of file-based metadata, right? It's not going to be as fast as like what data warehouses build. Data lakes were about unstructured data, both, but lakehouses are actually about just structured data. So that's another work in progress, right? So if you have to summarize, warehouses, it's formatting, okay. It's closed, lakehouses, open with conditions apply. I mean, you have open formats, but you have to really understand, I was having conversations today morning about, lock-ins on catalog, lock-ins on services, there are like other points you need to check, right? Then they're battle tested for been at it for like a long time, right? It's better for ML, data science, all these like large scale data crunchy kind of like workloads. Fully managed. This, as you know, you need to pick up some 4 or 5 open source projects, integrate and build it yourself. And expensive, from all the management as you scale, especially easy to get started, but gets very expensive as you scale the warehouse. But this gets, much cheaper at scale, right? So initially there's time needed for you to build a lake, but once you do that, then things are much cheaper and more cost efficient and a lot more flexible for you, right? So with this primer, what we're going to now talk about is something, like I was saying, the market compares these two all the time, but then there is the missing aspect that we don't talk about is how do we now, we have both these systems now, right? Just thinking like these tools at your hand, how do you combine them to build a very flexible and like a data architecture that makes sense? So that's what we're going to talk about now. And just to prove few things, right? So Lakehouse is like technically proven now. Like this is like a bunch of companies that are built on Apache Huri, and you can see it's like doing some of the largest brands. A lot of we moved the lake from many hours to kind of minute level latencies and near real time, and it's a lot of format wars and benchmark wars, and we had our fun and we try to do our bit here, and we have this project called One Table, which brings kind of like interoperability across formats, and it's basically most of the data is like a Parquet or a columnar file, right? So it basically does metadata translation and works across engines, but we want to move beyond that, right? And what we are really missing to see is a rare opportunity that we have at unifying the data architecture. So this is Gartner's 2021-2023 hype cycle for data management. You can see how the Lakehouse starts from here and like kind of jumps the hype cycle. So now I think the next 2 years is going to be a lot of productive, progressive work that's going to go on. So as somebody who's like worked on this technology like first and kind of was involved in the ideation of it with very real use cases, what I believe is the true change in this architecture is an opportunity to unify storage across warehouse and even batch and stream processing systems, if you will, right? And then also you can just do data management once across your data, across all these engines. So that's kind of like the big opportunity in my mind, right? And I feel like some of the thing where it's entering the trough is because users are starting to tire of kind of like format washing and stuff. You can pick up like one of these formats, but it's not going to solve the thing for you, right? End of the day, you need to build a flexible, stable kind of like architecture that can deliver value and flexibility and future-proof your data. So, but this is how typically what I see, and I've been like at the Hoodie community for almost 5 years now, working daily with people who are either have a warehouse and they're trying to build a lake, and they typically follow this pattern. They have like, you know, transactional data, they use some proprietary point-to-point tool, get it into a cloud data warehouse. They keep running ETLs until, you know, it, or they want to start a data science team, and then they start pumping events into S3 or like, you know, cloud storage, right? Because you really cannot send those events directly to a warehouse, right? So it's not really cost effective. And then they live in this like kind of world where they're running like, you know, kind of ETLs everywhere. They're copying data back and forth. It's kind of like a, you know, it's almost like a work in progress data architecture where data is constantly moving around of multiple data. So anything that you need to do, like if you need to do delete a record, it's hard enough to do it once, right? So you have to do it at multiple places, right? So this is still where things are, right? And this is where I feel like we're missing like the original plot, meaning like why, what are data lakes? Let's go back all the way back to that question, right? This is kind of like the version of the data lake that, you know, Martin Fowler's like data lake wiki, right? Which is, data lake is an architectural pattern, remember, and the basic idea is you land data in a raw form on cloud storage. So it's flexible, so you can go back and, you know, you can use the lake's kind of compute power and derive more and curate and derive more data sets downstream, right? And then in pop culture, this is now called the medallion architecture. If you look at the bronze, silver, gold, they're roughly mapped to kind of the picture on the top, right? So the key questions that we should be thinking about, at least also, is how do we deploy the lakehouse to its full potential? There's no point in having a lakehouse and then use it on one engine, and then, you know, you might as well be used like a proprietary system for that, right? So how about some of these questions? Which layer should be in what format, right? And when do you need to pay for like a premium engine? When can you use open source, right? And how to balance costs from day one? Why get into that problem and then try to fix it like 2 years down the line? How to achieve kind of like full interoperability, right? You need the thing to be interoperable, right? So these are some, I think, of the more fundamental questions, and it takes me back to the original data lakehouse deployment. I mean, it was before it was called the term existed, right? When we built Hoodie at Uber, these were what we were trying to solve, right? On the left was a file, what we call a file-based data lake, where we were doing bulk ingest, you know, it has essentially files on HDFS or cloud storage, and that we are rewriting and doing things to it, right? We moved this to a more transactional model where we brought all these primitives, right? This is, and then the problem that we are trying to actually solve is, before Hoodie, right, we were not able to bring database data quickly into the lake. We actually couldn't realize this data lake architecture that we talked about, where all data first lands in a lake, right? We really cannot curate anything really well. And so we wanted to get to fast, raw, bronze, silver data layers, so that once you do it fast, then you can power like, you know, multiple use cases off of it, right? And open formats when there was like interop. We use like 5 engines, right? We use Spark for data science, Presto for analytics, Flink for stream processing, Hive for your ETLs, and we still use the proprietary warehouse for the same reasons I talked about, because like, you know, the one that we used, it's gotten like a decade of engineering around like optimizing for these like BI workloads. So this is kind of like the other big idea we did was we decoupled the storage and the management of the storage from the engines, which meant things like clustering, compaction, cleaning, you know, indexing, file sizing, they're all done once at this level, and then all engines can benefit, right? I don't have to cluster it once for analytics and once for data science. You just do it once. So these were the main, you know, kind of advantages. And then here is kind of like what I'd summarize it as, right? I think to take, you know, full advantage of this sort of like data lakehouse kind of model, I think we should carefully think about different workloads you have. right? Not just think about like, hey, I'm going to pick one engine, I'm going to run everything on it. That's unfortunately not the right kind of like way to fully utilize this, right? We need to be like smart about faster engines can help a lot of places because it moves data faster and more incrementally down the stream. And sometimes slower could be cheaper because you could just like, if dashboards can load slower, you can run like a less premium engine, right? And then your price performance varies not just by engine. That's how I see most of the benchmarking done. It actually varies by workloads. So it's important to test the right workload on the right engine. And the other thing is you need to preserve your options. Like, think about 5 years. When I was at LinkedIn, let's say, the engines that we used were, big MapReduce, and then our format was Avro. And the big engine that was in the market right now is like Impala, right? Like, look at the engines today. So this is going to keep shifting, right? But you need a data architecture that can adapt when new engines are going to come up, right? Especially in cloud, right? Where you can try a new engine on the same data very quickly. It could be like a graph processing engine or like a specialized in-memory analytics engine, many things, right? The other thing is, optimize once, manage once. Don't do it many times. It's hard to do. Like I'm saying, even once it's hard to do. Deleting like, like a needle in a haystack across very large tables for GDPR and things like that, they're like very hard problems, right? You don't want to be solving them at multiple layers. They're very expensive problems to also solve at multiple layers, right? So with this, right, now let's try to kind of put these together into what like a alternate kind of like model would look like. It's actually very simple. I don't think it's like a big reveal or anything here. There's no magic ones. It's just a little opinionated, right? It's like very careful about what we pick in what layer. So at a very high level, what we are saying is let's have a lakehouse where you can flow database and events and all these things very quickly into, right? And then you have interoperability. There will still be a few years where you may have to copy the data into like a cloud warehouse if you want like the native performance of their proprietary format. So, but you can essentially pick that for a gold layer. So essentially keep your bronze and silver in a lake, keep it fast, manage it, and then you can pick gold is different for different workloads anyway. For data science, the gold layer, if you will, is essentially a Python or Scala code that you write, data scientists write into a notebook. The gold layer for data analysts do dashboard or some liquid dashboard that you build. So gold is different anyway. So streamline at the entry point and keep that interoperable. If a new engine comes up, you can always recompute from here, right? And you get like high quality data cleaned in this lakehouse that I'm talking about, right? This is roughly what we did back then as well, right? And these slides, I'm just going to like talk about few of these kind of principles, like I would say, and how these principles actually manifest, right? So one, big batch jobs on the lake. As we established, they're really good at that, right? Because they go right at raw cloud storage. You're operating at the speed of and scale of EC2 and S3. There's nothing in between, right? So big batch jobs, do it on the lake. Small ETLs can sit anywhere. You can't really, avoid them. But I see this problem where people write big ETLs on warehouses and complain about cost, right? So again, you will invariably write these jobs. So it's important to think about how your architecture can accommodate this, right? The small ETL can grow big, right? So you shouldn't be like doing system migrations when you do that, right? And move towards a more incremental model whenever you can, right? That is the other part of the lens that is not generally talked about, is how data processing has changed fundamentally with stream processing, right? And we barely applied most of these principles to the lake. So there's a big opportunity here to get more incremental. You need to be interoperable even with warehouses, and why not? The data is yours, right? And a lot of cases vendors control the roadmaps, but I think you should have that proactive conversation around, hey, I need my data in an open format, you should go support it, stuff like that. um, across all the engines. And essentially, you can, most of these open source engines, you can either use open source. There's usually a cloud service provider who will sell that, or there is like a company behind that, right? There's like 3 ways to buy everything. So you have like 9 buy these things, right? So make sure these things work across every different thing. And I would say the other thing is keep data on the lake as much as possible. Like there may be cases where you need to move to a proprietary format. For example, you may have to move data from a lake to a real-time system. That's unavoidable. You may have to move even some cloud warehouses, they have an in-process architecture, right? So in those cases, you may have to move data, but as much as possible, minimize the amount of data that you're managing away from the lake, right? And make sure your raw data lives on the lake. This is your most voluminous data, right? And this is what ETLs are good at crunching as well, right? It's a perfect, and you can recompute anything. That's the biggest thing I like about this. And you have a single source of truth. We had this issue like a lot at Uber. What we had people running the cities, and then we have data scientists building ETA predictions and things like that, right? They could not, they have to have the same source of data, right? If you look at our other architecture, if you're just copying data around, like data is always moving, right? It will not be in sync. So it's pretty much impossible for them to agree on some analysis, right? So those are like very important things to do. And manage data management, compute. You don't need premium. Most engines, let's say between a paid engine versus a open source equivalent, the difference is really for SQL planning and things like that. So none of this management workload really needs that. They're either very compute intensive, right? So why pay the premium for those things, right? And optimize it once, query it many times, like I mentioned before. Avoid data movements. And the other thing I would say, as a kind of anyway, I know I sound like what I'll point at the lake is we need to, figure out allow for more projects to be doing open services instead of dangling open formats as like a carrot and building like a proprietary thing around it, right? People should have like open data services, open ingest tools, open like table management tools and things like that. And I think as a whole, we need to improve on that. Choices on, world, these are specialized engines, right? And they're good at these workloads. And like I said in the cloud, right? You could be, let's say you have $100 for your budget, you could just be splitting them across 3 clusters very easily. This is not the on-prem world where you need to convince an IT team to buy like some hardware, and then you need to optimize one of these engines for that hardware. Different instance type, you can like do things very, right? So you need to think with that. External tables usually get ignored by vendors. Pluggability and performance, all these aspects. So again, ask hard questions, force your vendors to support them. Again, it's your data. Yeah, that's pretty much it. So at Onehouse, we're building on all like these ideas. We're building pretty much what we call a universal data plane, which can plug into many engines and kind of like does some of this, right? So learn more, go here. We're also hiring, so it's a small pitch at the end for the stuff that I'm working on. But yeah, hopefully this was helpful.